Good morning, y'all. In this video, we are going to introduce the reciprocal trigonometric functions, which are just the same as the original functions that you already know, sine, cosine, and tangent. But now the reciprocal would be 1 over them. And then the other thing is that in today's lesson, we're going to use the Pythagorean theorem, which you'll remember allows us to figure out the lengths of the sides of a right triangle. So most people learned it with the legs of the right triangle as A and B and the hypotenuse as C. The hypotenuse being the side that's across from the right angle. And then try to remember the equation is A squared plus B squared equals C squared, the hypotenuse square. When I taught this and wanted to help kids remember it, I taught it as S for the short leg, L for the long leg, and H for the hypotenuse. But it's leg square plus leg square equals hypotenuse square. Okay, cool. So remember the quadrants that we'll be working in. 1, 2, 3, 4. And this question gives the angle in radians. So we also want to think about how we would label the X and Y axes for radians. So remember, this would be 0 radians, 180 degrees would be pi radians, 90 degrees is half pi or pi over 2. And then finally, 3 pi over 2 for 270 degrees. So we read the question, given that the tangent of theta, and remember from SOHCAHTOA, TOA, tangent equals opposite over adjacent. Given that the tangent of the angle theta equals negative 12 over 5, where the angle theta is between pi over 2, which is here, and pi, which is here. So we can draw the terminal side of our angle like that. What is the value of the secant of theta? So this is what we're going to find at the end of the problem. We're going to find the secant, which is 1 over the cosine. So we'll have to find the cosine. Okay, cool. Let's use the information that they gave us in the problem. So remember that the opposite is the y. That's opposite the angle. And that the adjacent is the x. And now we're given the ratio, and we can use our side lengths and substitute them. So our y for opposite is 12. We'll deal with the negative in a minute. The 5 for the adjacent, for the x. And now if we look, we're in the second quadrant. In the second quadrant, our x is negative and our y is positive. We can see that. Our x is a distance to the left. X to the left is negative. So that's the negative 5 right there. And the y is positive because it's a distance up above the x-axis, so positive 12. Okay, cool. So now we know how long two sides of the triangle are, the two legs. Notice that our unknown here right now is the hypotenuse, because there's our right angle, and then across from the right angle is the side that we don't know. So we can use our Pythagorean theorem with the lengths of the sides. All right, so now when we substitute into the Pythagorean theorem, the hypotenuse is what we're trying to find. So C is what we're trying to find. This is our unknown. Here. So our legs, 5 square plus 12 square equal the length of the hypotenuse square. 5 square is 5 times 5 is 25. 12 square, 12 times 12 is 144. And that it equals C to the second power. 25 plus 144 is 169, which equals C squared. And now we can take the square root of both sides. We know that the hypotenuse must be a positive distance. So when we take the square root of both sides, C equals 13 units. So we can label that our hypotenuse equals 13. We're almost there. So cosine equals opposite over, sorry, that's a mistake, sorry. Ca is adjacent over hypotenuse. So then secant equals hypotenuse over adjacent, because the reciprocal will mean we can just flip the fraction. So to find the secant here, if we look our adjacent side, -5, and our hypotenuse, 13. So the secant of our angle theta is 5 over 13.